Good day. I think it's afternoon for everybody who's here, so good afternoon to all of you. Welcome to the GLOBE program's Great Global Investigation of Climate. As Mr. Hoffman pointed out, my name is Todd Ellis, and I am a professor at the State University of New York. The campus is located in Oneonta, New York, which is in the center part of the state. I am an atmospheric scientist, but I'm also an education and outreach leader for the NASA CloudSat mission. And part of my job with them is to work with that mission to study clouds and their role in influencing Earth's climate. So it's a really exciting time today because today is World Water Day, and it's an appropriate time to talk about climate and those issues. And so I'm excited to talk with you a little bit about what you have done and what you will continue to do to answer the question, what is your climate? In the part of the study that you've done thus far, we focus primarily on temperature and precipitation. As I said in the video, that was a deliberate choice because those are the primary atmospheric measurements we use to study weather and climate. In particular for climate, because they've been around for hundreds of years. And it's in particular since the late 1800s that scientists realized that it's important that these measurements should be taken the same way every time, using similar instruments at every station around the world so that we have something that we can compare. And for our friends from New Jersey, I think it's really interesting, one of the things that you're studying is the influence of the kind of land cover that exists around your station. Imagine what would happen to an atmospheric site if it used to be in grassland and then all of a sudden it's paved. I would be willing to bet that your temperature record would show an increase in temperature. So the study that you're doing is really, really interesting and of significance to the scientific community as a whole right now as we study climate. So good job, and that's a really good choice, and I hope that you continue to study that. Now, at this point in the study, it continues to be very important that you observe temperature and precipitation following the protocols as often as you can. Because while you probably had a chance to do roughly 2 weeks worth of data at this point in the study, we need much more than that in order to begin to really establish what the climate of your site is. In fact, you should always remember that we define climate as a long-term average, and scientists usually require at least 30 years of data before they feel confident in declaring that average to be a statement of climate. So once you have those data, 30 years or more worth of temperature and precipitation and some of the related variables, a scientist would then be able to answer questions like, what is your average temperature? How often does it precipitate at your location? And what is the most rain that you've ever had at that location? Those are all questions related to your climate and can only be answered with a long data set. These and other questions are related to some of the many studies that continue to be going on today. What's interesting is that it's not just atmospheric scientists that care about these kinds of things either. It may not surprise you that a lot of life scientists are interested in climate because it affects something known as phenology, which is the effect of climate on when vegetation and animals appear in their seasonal cycles. GLOBE has phenology protocols, and one of our partner schools in Croatia is currently doing the phenology study in addition to their atmosphere and temperature protocols to learn a little bit about how their climate influences when their vegetation comes up in the spring. That's a great example of how you can study the effects of climate on the environment. This connection between climate and environment actually gave rise to another activity that's part of this great global investigation of climate. In the early 1900s, Vladimir Copa developed a climate classification system for all of the climate types around the world. And he did so using annual and seasonal patterns of temperature and precipitation, as well as vegetation types. This was then updated in 1954 by Rudolf Geiger, and he in turn turned it into a world map, which I'll show you here momentarily. This system today is known as the Köppen-Geiger climate classification system, and it's widely used and identifies 31 different climatic regions around the world. These are generally broken down into 5 major types. They are the equatorial, the arid, the warm temperate, the snow, and the polar. Each type then gets further divided down, and I'll show you momentarily how you can see how some of these fine characteristics come into play in identifying the local climate at your location. But what's interesting is what defines a climate classification at your site may be things such as how far from the equator you are, how far from a large body of water you are, and even something that maybe our friends in Estes Park, Colorado might notice, altitude or elevation has a major role as well. That climate classification then becomes an important part of understanding how temperature and precipitation influence your climate, and then help you then understand the kinds of plants and animals you have. Now the thing is, it's hard to determine your own classification unless you've got 30 years of data. So we've tried to help out. We have provided you with 30-year data sets of temperature and precipitation data from cities around the world. They represent all of our globe regions, and more importantly, many of the different climate classifications. Using these data will assist you with the climate classification activity. So I'm going to advance the slide here and show you that on this slide is a Google Earth map with a plugin that shows some of the sites that are participating in the Great Global Investigation of Climate. The web page that's listed here has instructions on how to participate in the climate classification activity. But what I want to share with you today is an example of how that activity can be useful and lead to a lot of other different activities. Let's say, for example, you want to look at a particular site, like we're looking at Northern Africa now. You can turn on a level on Google Earth, a Google plugin that shows you where all the different schools are, and then you can also turn on a layer that says show the Köppen-Geiger classification. And notice that the map is now colorized, and the colors represent many of the different classifications. More information on what each of these codes means can be found on the web page with the climate classification activity. One of the things that we're really interested in is, as you participate in that climate classification activity, if you would share your results in the discussion forum called Our Climate Classification. That way, other schools that are participating can talk a little bit about how they determined their climate and whether or not what they determined matched the world map of the Köppen-Geiger climate classification that you see here. As a way of doing that, you can actually get one more piece of information off of this, and that is if you click on one of the sites, in this case, a participating school in Cameroon, you can get that 30-year data of temperature and precipitation, which is vitally important to being able to determine the climate classification where you live. So again, these data are for you to use to participate in the climate classification activity. But it also opens the door to a couple of other opportunities. For example, you might then be able to, in that forum, communicate with other schools and compare what makes each school's climate classification unique. You know, maybe there's a particular kind of animal or plant that's interesting there. You can ask each other questions about how you determined your weather and your climate classification. And the thing that's most interesting to me as a scientist is the opportunity to be able to collaborate with another school, maybe in a similar climate classification, but maybe in a different hemisphere, and look at how different or how similar your climate statistics are. Plus, you've now got 2 weeks or perhaps more of data that you can use to compare to what the climate average is. And ask yourself, has your weather been normal compared to what your climate would normally be? Or have you had an abnormal winter? Here where I am, it is winter, and we have had an abnormally snowy winter, much more precipitation than normal. That's something that you can study with these data. So there's a lot to get into, and I'd like to make sure that we have some time that I can answer any of the questions that you have. But before I do that, please let me reiterate that there are opportunities for you to participate after this webinar, partly with general questions about weather and climate. This discussion forum is one that I monitor regularly, and I'm always willing to participate in if you have any questions. And this forum here, the Our Climate Classification Forum, is a forum that is meant for you to share the results of your climate classification activity. So I highlight those because the project doesn't end today. But I'm going to pause now, turn the control back over to Martos, and let him moderate if there are any questions from those of you who are watching. Sorry, forgot that I didn't have my microphone on at that moment. Considering who our friends are that have joined us, one of the things that I'd be interested in, if you're willing to share, is if you've learned anything about the influence of land cover on temperature at your particular site. I know that's something you said you were studying. 2 weeks is a short time to make conclusions, but I'm curious if you've seen any patterns emerging. That's something that I'd be interested in addition to your questions while you're formulating those.
You are now unmuted.
Yeah, I'd love to answer that question because I really think that's the most important part of this study to me. It's one thing to learn about your own climate, but sometimes it's easier to learn about what makes your climate unique when you start to compare it with all of the other different kinds of climate around the world. And we're very fortunate to have had schools that are participating and have been participating in this project that cover both the eastern and western hemispheres, some in the southern hemisphere, some in the northern hemisphere. And there is a wealth of opportunity then to take a look at what their long-term average data are, compare them to your own, and ask them questions like, how's their season, whatever season it happens to be at their location, if they have seasons? That's an interesting question in and of itself. How have they been climate normal? Has the weather been different from the 30-year average? I know there have been some abnormal weather patterns around the world over the last few weeks, and it would be interesting to find out if people have seen those. I would also highly recommend actually asking each other questions. It's very easy to look at somebody else's data, click on another city, and compare those long-term data to your long-term data. But I think it's more important to talk with other scientists. And all of the students who participate in this are scientists. Ask each other questions about what interesting things you learned. What sorts of things did you think affected your measurements? You'll find that every site that measures temperature and precipitation has its own unique quirks. And sometimes they have a really interesting impact on what you measure. So asking each other questions via the forum, I think, is really important. It models what scientists do. We get together at conferences and ask each other questions all the time. It's a really important part of being somebody who is inquisitive, which is what really defines us as scientists. If you are always curious about why, then the next step is to start asking other people, well, why did you see what you saw? This is what we had. There's something to compare. That's, I think, what I'm most interested in, and I think it's the opportunity that you have that through the GLOBE program that you otherwise would miss. I hope that answers your question. Looks like it might have, so that's a good sign. You know, it's a really good question. I think I always love the land the land cover classification protocol because of course it involves this this book of codes called Muck codes, and Muck codes just sounds like a really good environmental study process. You know, because how often are we out in muck, especially if we do, say, hydrology protocols? My answer to the question is not explicitly. However, we do modify it some. As you look into the climate classification activity that's been prepared, there is some land cover identification in there. Certain kinds of trees, for example, are indicators of certain kinds of climate. One of the best ways to notice this is the next time you're in the mountains, notice how the types of trees change as you go up in elevation. Since I know you folks are in New Jersey, a really cool place to see that is a place like Mount Washington, New Hampshire. Yeah, you have to pay money to drive up the road, but it's a really cool drive. And you really see the land cover change as you go up. And you do end up transferring from a sort of more temperate climate classification to one that is more alpine and actually shares characteristic with the snow-covered and polar climates than they do with temperate zones. But land cover is only part of it. The temperature and precipitation long-term averages are as important as the land cover is. You put them together and you get a complete picture of the climate classification. That was what was unique about the Copa and Geiger system. And it's something that I hope you get a chance to explore. I think you'll be able to do that even though New Jersey tends to be fairly urban. There's enough plant life around and you'll have enough to compare with your temperature and precipitation, and really I think you'll be very successful identifying the climate classification you're in. I hope that answers your question. Is there anything else you'd like to know about that? Okay, so I see a follow-up question asking how the Copa Geiger classification compares with Muck. The answer is they're sort of meant to do two different things. They compare fairly well. I would feel more confident answering that if I had them side by side in front of me. But the skill sets are similar in that you're identifying the kinds of trees, you're identifying the kinds of other materials that are around. And I do believe that the climate classification activity, again, unfortunately, I don't have it sitting right in front of me, or I'd be a little more confident on this. But the idea is that you sort of go through a bit of a dichotomy, I believe, to identify where your plant life sort of falls in the climate classification system. I'm kind of keeping an eye on some of my colleagues to see if anybody's screaming at me to say that I just said something wrong. But I think that's how they compare. Certainly the skill set's the same. You're identifying the kinds of plants and adding to that the temperature and precipitation data, which is probably the more important of the two, but they definitely are very important to be used together. Muck codes don't require any precipitation or temperature data. You classify that solely on what you see on the ground. Yeah, and in fact, Martos just kind of responded to exactly that point. The climate classification system involves the temperature and precip, while the Muck codes is all about the land cover. So does that answer the question from our folks out in New Jersey? Well, that's an interesting question. What is the most common climate? You know, you can investigate this on your own, and I highly encourage you to do that, but I'm not going to just cop out and not give you an answer. The more common climates have to do with primarily your distance from the equator. That's almost always the number one driver of the kind of climate that you live in. So the next time you think about it, pick up a globe, not a map of the Earth, but an actual globe, and look at just how much land area falls between 30 degrees north and 30 degrees south. If you were actually, took the time to measure that, you would find that half of the Earth exists in that band. That band is primarily tropical. So probably the most common climate classification type is the equatorial, simply because that's half of the land mass. That would be my initial guess. A fairly educated one. I feel pretty confident about that. There are plenty of arid zones. They tend to be centered on certain latitude bands. And that's one I won't answer for you. Have a look at the climate classification map and see if you can identify at what latitudes most of the world's arid zones occur. And I'll give you a hint. If you know something about how the atmosphere moves, there's something we call the general circulation of the atmosphere. You may have heard of it as the Hadley Cell. The Hadley Cell has to do with where most of the world's deserts are. And that could be a really interesting investigation. We even have a couple of schools that are right on the edges of some of those bands, and that could be an interesting investigation. So that's my answer. The most common is the equatorial, the A classifications under the Copa and Geiger system. And that's an excellent question. One of many things I would hope that you get a chance to explore a little bit. It can get addicting, taking a look at that map and trying to find all these really neat things about the kinds of climates that exist in places you might not expect them. Yeah, I just want to thank you for the great questions. There's actually a little bit of a debate going on between one of my colleagues and I who thinks that it might be the arid climate that's the most common, which is still an equatorial climate. It's just a dry one. So it's worth investigating, and that's really the theme here, right? The GLOBE protocols are about tools. They're tools for you to do your own investigations. So the important thing to remember is as you continue to collect and enter data, do so as often as you can, and don't be afraid to ask your own questions about it. Share those questions with us in the forums. We'd love to see what you're up to, and it might inspire other schools to ask similar questions or maybe amplify on yours. That's how the scientific process was designed to work, and I'm hopeful that we can model that. You've got the tools and the talent, and hopefully you have a chance to use them to learn more about your climate. Thanks very much for your time, and please feel free to chat with me if you have any further questions. And happy World Water Day.